So this example 2 in the book, this is also a rational equation. The difference now is that we don't have like a 3 and a 4, which is pretty easy to find common denominator. We've got variable expressions, right? So remember, as a first step on this one, we need to factor the denominators. So 1 over x minus 2 equals 3 over x plus 2. How do you factor x squared minus 4? Oh, okay. Okay, what do you call that? Difference of squares, right? X plus 2, x minus 2. Okay, now find the common denominator. Do you remember how to find common denominator? Write down all the factors that you see in all the terms. So in this case, there's an x minus 2 in the first fraction. There's an x plus 2 in the second fraction. Okay, in the next fraction, there's an x plus 2, but you already have it, so you don't write it again. There's an x minus 2, but you already have it, so you don't write it again. So the least common denominator is x minus 2 times x plus 2. Okay. Now, multiply every term by that. So x minus 2 times x plus 2. X minus 2 times x plus 2. X minus 2 times x plus 2. Okay, now cancel the denominators, right? Because the least common denominator includes all of the factors in the denominator, you should be able to cancel all the denominators. X minus 2 cancels with an x minus 2. X plus 2 cancels with an x plus 2. X minus 2 and x plus 2 cancel with the denominator. Okay, so what's left? X plus 2 and 3 times x minus 2 minus 6x. So again, we had to factor, find the common denominator, multiply by the common denominator, cancel the denominators so that we have something that's easier to solve. Now we'll solve it. X plus 2 equals 3x minus 6 minus 6x. X plus 2 equals negative 3x minus 6. Okay, it's definitely going to be linear, right? It's all x to the first, no squareds or anything. So we know we need to just get all the x terms on one side, all the numbers on the other. Let me add 3x to both sides, plus 3x. Now we've got 4x plus 2 equals negative 6. Subtract 2 from both sides. Minus 2, minus 2. 4x equals negative 8. X equals negative 2. But now it's where it's important that you got to check your answers. Because what happens if I check x equals negative 2 in the original equation here? Negative 2 plus 2, I'm dividing by 0. Negative 2 squared would be 4. 4 minus 4 is 0. It would lead to a divide by 0. So we solved this correctly, right? But the answer that we found would not work in the original equation. That means no solution, right? Divide by 0. Right, that means up here and here. So you say no solution. We found this specifically sometimes with rational equations, sometimes with radical equations, that when you check, it doesn't work. Usually you call that extraneous.